Hello, welcome you for this session Fourier Transform. In this session, we are going to discuss Parseval formula, Parseval identity for Fourier series. This is a theorem is there. So, suppose the Fourier series correspond to f of x converges uniformly to f of x in the interval minus L less than x less than 1. It is looking like 1. It is not 1, it is minus. It is minus L and x less than L. Then 1 by L integral minus L to plus L f of x whole square dx is equal to a naught square divided by 2 plus summation an square plus bn square, where the integral on LHS is supposed to exist, right? Proof. Let the series f of x converges uniformly to f of x at every point of interval such that f of x, this is a Fourier, everyone we know that f of x is equal to a naught square by 2. It is a naught by 2, right? A naught by 2 whole square you have to remove, by mistake it is came a naught by 2 plus summation an cos n pi x by L by n plus bn sin n pi x by L dot dot, it is equation 1, right? So this is what the term by term integration of this is possible. An is equal to 1 by L minus L f of an is equal to, this is a formula we are knowing very well. An is equal to 1 by L integral minus L to plus L f of x cos n pi x by L dx. This is bn, only the change will be here, that is instead of cos you will get sine. Now multiplying the equation 1 f of x and integrating term between minus L to plus L. What is equation 1? Okay, this is the equation 1. What you are going to do? Here you are going to multiply by equation f of x and integrate it with limits as minus L to plus L. This is the step. I am just okay, this is the step. So after multiplication you can see over here minus L to plus L, f of x is one more is there already, so one more time you will, therefore you will get f of x square dx is equal to a naught, it should be a naught, not square, a naught divided by 2 integral minus L to plus L f of x dx plus summation an integral minus L to plus L f of x dx cos n pi x by L by n dx plus bn integral minus L to plus L f of x dx sin n pi x by L dx, right? This is what the thing after multiplying the equation 1 by f of x and integration. So here, yeah, now I made it is correct. A naught by 2 integral minus L to plus L f of x dx is there, plus this many terms is there over there. Now what will happen? A naught by 2 L into a naught. A naught, those who have done Fourier series, a naught is given by what? 1 by L minus integral minus L to plus L f of x dx, right? Therefore it is there. A naught by 2 L should be balanced, 1 by L is there, therefore L into a naught. So plus summation L is extra thing is there over here, 1 by L will come as an. So an square plus bn square. So after final adjustment we will get in this form. L will be the common, so yeah, 1 by L in integral minus L to plus L f of x whole square dx is equal to a naught square by 2 plus summation an square plus bn square. This is most important theorem. What I feel is f of if f of p and g of p are the complex Fourier transform of f of x and g of x, 1 by 2 pi integral minus infinity to plus infinity f of x g bar of p dp is equal to integral minus infinity to plus infinity capital F of x capital G bar of x dx. Second one is 1 by 2 pi minus infinity integral minus infinity to plus infinity mod of f of p whole to the power 2 dp is equal to integral minus infinity to plus infinity mod of capital F of x whole square dx, where bar represent complex conjugate. So let me try to prove this one. Using inverse formula of Fourier transform, we have what is that f of x, here g of x they have used. G of x is equal to 1 by 2 pi minus infinity to plus infinity g of p e to the power minus ipx dp. Let me say equation 1. And conjugate of g of x is equal to 1 by 2 pi integral minus infinity to plus infinity g bar of e to the power ipx dp. Equation 2 it is. Now what I will do is that I will multiply. Wait a minute, I have to show this one to you. It's not moving right here. Yeah, in equation G2, equation 2, what I will do is that in next step, I will multiply and integrate this one, both side. If you do that, you just see what will happen. Integration minus infinity to plus infinity f of x, g bar of x dx is equal to, both side I said, minus infinity to plus infinity f of x dx, whatever is there, 1 by 2 integral minus infinity to plus infinity g bar of p e to the power minus ipx dx is there, right? 1 by 2 pi you take outside, and integration I will write minus infinity to plus infinity minus infinity to plus infinity capital F of x g bar of p e to the power I p x dx dp. What if you want to do with, first what it is that you want to do with respect to x, then resultant with respect to p, right? But if I want to change with respect to p first, then after that with respect to x means I have to change the order. So if you change the order, it looks like this: 1 by 2 pi integral minus infinity to plus infinity integral minus infinity to plus infinity capital F of x g bar of p e to the power ip of x. Here instead of dx I will write dp by dx. I have made order of change of order of integration. So it looks like 1 by pi integral 0 to infinity g bar of p dp I will take out in one integration. Another integration I will take integration minus infinity to plus infinity capital F of x e to the power minus ipx dx. Okay, so half into e to the power integral e to the integral minus infinity to plus infinity g bar of p dp. This is nothing but Fourier inverse Fourier transform. So therefore I wrote as f of p. So same thing. Now equation third will become as 1 by pi integral minus infinity to plus infinity f of p g bar of p dp is equal to 3. Okay. Now putting, so this will get as, wait a minute, it went a little bit back. Now put what it is, wait a minute. Yeah. Now put what it is, that is we will get equation 3 and 2, we will get this one, uh, g g bar of p as f of p. So what you will get, integral minus infinity to plus infinity capital F of x whole square dx is equal to half into integral p square. So using this formula, Parseval identity, let me try to do some problem over here. Here you have to take f of x as e to the power minus x. Why? Because it is there. Now try to find the cosine transform. Cosine infinite transform. Cosine infinite transform is, yeah, here 0 to infinity e to the power minus x cos sx dx. So you do the simplification of this, and you will get this in, after supplying the upper and lower limit, we will get 1 by s 1 by 1 plus s square. So we have this result, just possible result, 2 by pi integral 0 to infinity f c of s whole square ds is equal to integral 0 to infinity capital F of x whole square dx mod. The same thing I'm going to write here. Yeah, here small f inverse I got as 1 by 1 plus s squared whole square ds is equal to integral 0 to infinity capital F of x is e to the power minus x whole square dx is equal to half. It will get as half when you do the integration. Therefore the resultant answer for this is integral 0 to infinity dx by 1 plus x square whole square is uh, pi by 4. I hope you got the things properly. Thank you.